Question 9. Point A with x coordinate of 2. The x coordinate, the x will be 2. Lies on a curve y equal to set for x plus 1. And this is the curve. This diagram shows part of the curve and tangent to a curve at A. This line is a tangent at A. Find the area of the shaded region enclosed by the curve, y-axis. This part right here. So we need to find this area. Step 1, when they say lies on the curve, it means that our A will obey the curve equation of this one. And then we know that x is equal to 2. So to find y, we just substitute it in the curve equation. For we substitute 2 plus 1. Simplify this. 4 times 2 is 8 plus 1. And this one is 9. Y will be equal to 3. So here we know it's going to be 3. So after we have our limit, for us to get the shaded region, which is this one, what we can do is, first, we find the area under the straight line. So area under the straight line, this is going to be x at 2. And we need to find what is here. Then minus the area, the curve. So this is the curve. The area under the curve, that would be at point A, which is also equal to 2, but we need to find x over here. X, and this is another x, x1. Let's just name it x1 and x2. Now, if we find the area down under the straight line and then we minus the area under the curve, we will get the area enclosed by tangent and the x-axis. So how do we do that? Area for the triangle, 1 over 2 times base times its height. So this part right here would be the base, and this part right here would be the height. We know that the highest point here is 3. We already have the height, but we need to find this part right here. Do we do this? We know that here y will be equal to 0. So what is our x for a straight line? This is a tangent line, and we have tangent equation. Y minus y1 equal to a gradient, or m, x minus x1. Now, if we want to find the gradient at this point, we know that tangent is equal to dy dx of a curve. Y is equal to, let's differentiate this. 4x plus 1, 1 over 2. So this is just power rule, power bring in front, and then inside we have another function, so we need to differentiate inside. Differentiate 4x plus 1, that would be just 4. So times 4 over 2. The inside part remain the same, and then 1 over 2 minus 1. Chain rule, differentiate inside, that's going to give me 4. Simplify 4 and 2, 4 over 2. 4x plus 1 remain the same. If 1 over 2 minus 1, that is negative 1 over 2. Simplify this. This is 1, this is 2. My final differentiation, 2 over 4x plus 1 set. And this is my dy dx. Now I want to find my dy dx over here, which is m, or my gradient, at x is equal to 2. When x is equal to 2, then my dy dx will be 2 over 4 times 2 plus 1, 2 over 8 plus 1, 2 over 3. Now I have my m, which is 2 over 3. Do I have my y? I'm going to use the same value of coordinate, which is 2 and 3. 3 for the y. 3 for the y. And then this is the m at x equal to 2. And then this part right here would be 2. I'm going to bring this over that side. Y is equal to 2 over 3x minus 4 over 3 plus 3. This, simplify the behind part, 2 over 3x plus 5 over 3. Now this equation will represent this straight line. Okay? Now my goal is to find this, what is the x. Since I know y over here will be 0, I'm going to substitute 0 here. 0 equal, when y equal to 0, then 2 over 3 x plus 5 over 3 minus 5 over 3 equal to 2 over 3x be 5 over 2 minus. So now I know here at this point, when y equal to 0, my x is negative 5 over 2. And I'm going to need this limit. Here, y is equal to 0, but we have our own equation here. So what I can do is just that when y equal to 0, 0 equal to 4x plus 1. 4x plus 1 equal to 0 minus 1 over 4 is equal to x. So here, okay, now I have my value here, a negative 5 over 2, and here is negative 1 over 4. Now, let's substitute to triangle equation 1 over 2 times the base. So minus 5 over 2. 2 minus 5 over 2 times the height, which is 3, minus integration the limit negative 1 over 4 to 2 of the curve, which is this one, dx. Okay, let's simplify the first part. This one I'm going to get 27 over 4. Now, for this part right here, what I need to do is I will use substitution. Sub u is equal to 4x plus 1. du will be 4 dx. dx will be du over 4. Just take this and bring it over here to make dx as a subject. Now, if I substitute this, okay, to get this part right here, I'll be substituting this for x plus 1 with u, 1 over 2. The x over here, I need to substitute this one, du over 4. Now, for me to integrate this, I know that 4 is a constant, so I can bring it outside of the integration. 1 over 2 du. Now, this is easier for me to integrate because this is just power rule. Bring in front and then plus 1 over 1 over 2 plus 1. u 3 over 2 over 3 over 2 times 1 over 4 with the limit of negative 1 over 4 to 2. Simplifying that will give me 1 over 6 u 3 over 2. Okay. Now I'm going to bring all this on one side. Now let's put in the limit. So 1 over 6 u, substitute back u for x plus 1 over here. Upper limit, substitute in x, minus lower limit, substitute in x. We are substituting 2 for the first part and negative 1/4, the lower limit for the second part. Now let's simplify this. It's 8 plus 1, which is 9, 3/2. This can be written as square root 9 power 3. Square root 9 is 3. 3 power 3 is 27. So the first part here will be 27. And this part right here will be 0 because 4 cancel out. And then minus 1 plus 1, that is 0. So 0 power 3/2 will be 0. So behind is 0. We will get 9/2. And to get the area, this is, to simplify this, our final answer, this 1 times 2 times 2, 27 minus 18, that is. So the final answer is 9/4 unit square because it's area. So let's compare with the marking scheme now. The first mark is coming from when we get our y equal to 3. So that is here. When we substitute x equal to 2 from this hint, and then we get our y, that is going to give me 1 mark. Okay, so 1 mark. And then we try to find the gradient of a tangent. This is, we differentiate it, you're going to get 1 mark. And then we have our tangent equation, that is 1 mark. We know that when x is equal to 2, our tangent is negative 5/2. 3 marks, right? So equation of a tangent, 1 mark. Our gradient, 2/3 is our gradient. 1 mark at our x, it's going to be equal to negative 5/2. So that is here. And we do for the area of triangle. Area of a triangle, this part. This one. This is 1 mark. And then when we find our intercept at this curve, which is 1/4, 1 mark. And when we find the area under this curve, 1 mark. And when we know to apply the lower limit correctly, which is this part right here, this is 1 mark. When we finish by minus the 2 area of the triangle minus the curve, we will have our last answer, which is 9/4 here.